Learners, this is the part 2 of the breaking down of the marks whatever will be given by the examiner whenever your paper will be checked. Here particularly I am resuming the number based program that I was checking in my previous video, if you have observed this carefully. So let's see what the student has done. This is tomo tumorphic tumorphic number. So up to this I think you have already observed in the previous class what all marks will be denoted if you have done certain mistakes. So in this particular part we will be working on some other parts, but see here the student has not mentioned the question for me. Okay, so let me then focus to this particular part. Java program to check whether a number is unique number or not. What is said to be as unique number? A number without repeat, okay, without having zeros and no duplicate. See, without leading zeros. Acha. And no duplicacy. So those particular numbers will be said to be as, is it, leading zeros, right? And it has not to be, there has not to be any duplicate numbers, that will be said to be as my which number, unique number. Before going through this we need to also observe what do we mean by leading zeros. Leading zero means if you are having known numbers at the beginning, like if I will be having 0 1 2 4, this will not be said to be as a unique number. This is one of the case. And if I'm having any double digits 4 2, see here I'm having duplicate digits, it is not said to be as a unique number. Let's see how the student has written. So this scanner, the package is declared, so that number will be accepted to check whether that particular number is a unique number or not. Here this student has declared the statement, but here as it was just for the homework purpose, so he has it in SOPLN. But in the examination that is why I am every time asking the students not to write this, because in the examination as well in hurry worry you will be writing SOPLN. Okay, so for if this would be written in the examination, teacher will be irritated by this creates bad impression on the examiner. So here the number is accepted. Now number n is equal to n, correct. Number, now let's see, so here what we need to actually check, the digits are same or not. So let's see how the student has checked. After a number is picked out, acha, after a number is picked out, the student has taken another loop. Acha, if r is equal to okay, by using, what has he done, but he has checked over here. What has he done? 1 2 4 9. At first he has picked out the last digit and he is checking whether this particular digit is present in all of this particular place or not, and for that he is using a counter, and he is checking if my counter is 1, which is because as the number is already present here of course the counter will be 1, because here there will be a single duplicacy. Do you understand? The number 9 is taken over, and here it is checked whether it is present in all the places or not, and once it will be finding that yes it is present, it will be containing 1. If it is containing the 1, what does that mean? That means it's not duplicated, right? Because it is also checked here. This is what the student has done. See, as soon as a digit is extracted by using another as soon as one digit is extracted, rem, here the student is checking whether it is present in all other places of the number or not. If it is found that it is present anywhere, this particular line, then what is done? K plus plus. As soon as this loop will be completed, what is stored in n? So the number n is equal to uppercase n. So yes, the number n is storing the uppercase n, that is the original number. But here k is equal to 0, then k is checked. I think it's incorrect. First you have to check whether your n is greater than 1 or not. If your n is found if your k is found to be greater than 1, then what you need to do? You need to break. You need to break, and after it will be break, it will be checking whether the number is equal to 0 or not. I think it's crazy. He has gone wrong somewhere. I think this has to be, you shouldn't write k is equal to 0 here. You need to check whether the number of duplicates is greater than 1 or not. If it is yes, then break. And if I'm finding k is equal, here also I can write the same thing. If I'm finding k is ever greater than 1, sorry, is equal to 1, then it is a unique number, otherwise not. This has to be done. After all of this process, if I am finding it's not greater than 1, then break will not be executed. Then here I need to write k is equal to 0, and this is my independent statement. I think this is the correct way that the student could have written. He has gone wrong in some other place, and this is where the whole while loop is closed. The outer while loop is closed here. I think this is the correct way. After all of your checking of the k, then what will be done? Then here my k will be taken 0, right? So for the second time, what will happen? Again 4 will be picked out. 4 will be checked starting from this particular place to this. And here what will happen? Obviously, whenever you will be having only one unique digit, k will be every time be 0. And if you are finding anywhere duplicates, suppose 1 2 2 4 8, so what will happen? When it will be coming to this place, for this my k will be increased to 1, and for this place my k will again be increasing to 2. So here my k has become 2. If my k is anywhere becoming more than 1, so it is said to be as that it is having a duplicate digit. I think this is the correct way that the student could have written, but he has gone in some other way. Okay, let's see for this particular program how much marks student will be getting. Here we can expect around 11 to 13 marks, because only as this was a small minor mistake. No, when this particular program you will be learning in Bluesy, you will be not getting the proper output. But as you are just building up and you are writing program, I could say from 11 to 12, between 11 to 12, the examiner will be denoting you the mark due to this particular error that you have done. Okay, now let us go to another program. Niven number. What is this Niven number? Is it explained? No, the student has not explained this. Okay, we will be coming to this particular Niven number part after we will be observing other. Then I will be finding out the correct definition to this, and we will be checking whether the student has written it correctly or not. And here let's see, Niven number is over. After, okay, this is Krishnamurti number. Wow. It's a very good question. Sum of factorial of all its digit of a number is equal to the original one. Let's learn from the example. Suppose user has given 145. Okay, so so the factorial of each digit has to be picked out, and if factorial of each digit has to be picked out, and if they are added all together, if we are finding the original number, then that is said to be a Krishnamurti number. Okay, let's see how the student has done. Scanner is declared, class is declared, this a statement is written to accept a number from the user. Then the student has stored the number in some other, but has not provided the semicolon that was necessary. Each digit is picked out. Okay, after each digit is picked out, what we need to find? We need to find the factorial of that particular digit. Let's see. Yes, exactly correct. Now I need to check whether, see, when I have come to this particular page and I am not noticing anything other, here what will I be checking? When I have reached here I will be checking whether this f is declared or not. And once I will be observing f is declared, I need to check whether the f is initialized 1 or not, because here we are doing product of the range of numbers, so it has to be. Let's see what the student has done. Yes, it is declared, and after so much cutting, the student has stored 1. Okay, so here very beautifully f will be now be storing the factorial of the number. But I don't know why the student has printed the factorial, because it has not asked. We need to store the sum of the factorials, right? So this is stored here, and I need to check any other two things, whether s is declared or not, or is my s is initially 0 or not, because here I am adding them up. Let's see. Yes, here s is equal to 0 is done, and as it is stored in int, it is absolutely correct. So after this all doings, I need to, so here the student has done f is equal to 1. Yes, f has to be 1, because for the next time whenever my inner loop will be working, if my f will be raised or will be remain same as it is, so it will be starting from a different sort of numbers. So this is an initial step. Okay, teacher, your examiner is impressed here. Yes, the student has very mindfully changed it to the initial value 1. Now again n is equal to n modulo n divided by 10. Very nice. Where is the inner bracket closed? But here the problem that I can observe is I'm not observing where is this inner bracket closed. Okay, yes, it is closed here. See, it is not identified because due to lots of cutting, and here my outer bracket is closed. Correct. And if my sum, see, here is another mistake. The student had stored the sum of the factorial of the digits in the variable s, but here the student is checking in the variable sum. It has to be s, right? See, here is the confusion. That is why every time you need to be very much properly, you need to focus the variable where this all things are stored, and in which number you are checking. See, everywhere my n is checked, and my n is changed. That is why at first initially my n is very safely stored in copy n, right? But here I think it has to be declared. This is the problem. Can you see? Here it is only initialized. It, let's see, it is declared or not previously. Yes, it is declared. Correct. Right? Yes, correct. So as my original number n is changed in some other place, that's why initially I have stored the copy of my n in copy n, so that copy n will every time be storing the original number, if even though any manipulation is done in my variable n. So see, after this is correct, this is correct. Here my main method is closed, here my class is closed. Okay, so for the small wrong what the student has done, for this 12 to 13 out of 15, the student will be getting marks, or even 13 to 14, because here in some other parts the teacher will be, if the examiner will be impressed by some of your doings, so your examiner can give 13 to 14. Okay, now let's come to another program. What's this? This is multiple Harsad number. Definition I am unable to observe, so let me skip for this time. Then multiple Harsad number. Yes, I could feel multiple Harsad, but why is this going some other way? Okay, multiple Harsad. Let's see. So if I have taken a number from the user, here it is 6804. If I will be finding the sum, that is 18, and if I will be dividing the sum with that particular number, and I will again be doing the same thing, and if it is done till I have got my number one digit, is this what has to be checked? Just a moment. Multiple Harsad number, and everywhere 18. After this is 18, then 21. Let's see. This, after we have got the number, just a moment, what the student has done over here. The student had stored this sum. Is the sum of digits are stored? No, not that. After each digit is no, when a number is given the sum of the digits, then the number is divided it with the sum of the digits, unless and until we are getting a single digit number. After a single digit number we are getting, there we are printing. Is a single digit number if we are getting, but we will be getting the single digit, right? At some point of time, if we will be keep on dividing the sum of the number with the given number, sum of the digits of that particular number with that given number, there will be a time when this will become a single digit, right? Okay, from here I could notice that, okay, every time, and yes, we have understood this particular thing, that every time it's not everywhere that your sum of digits will be divisible with the given number. Suppose if I have taken 19, the sum of the digits will be 10. My 10 is not divisible with this 19, right? So here it says that multiple Harsad number is a particular number that if you are keep on dividing the number with the sum of digits, there has to be a situation where you will be getting a single digit number that is also a Harsad number. So here what will happen, if a number will be, if you are getting every if you are able to bring, or the number is found to be Harsad unless and until it is becoming a single digit, then of course that single digit will be also considered to be a Harsad number. See, here my number is 7, and here if I will be dividing it with the sum of digit, that will be 7, right? And I will be getting the remainder. So my doings need to be, I need to check whether it is able to produce a single digit number or not by this particular processes, by this particular Harsad number. Let's see what the student has done. So the student has taken the number very particularly, and has what has done, the student has stored the sum. Okay, after a sum is stored, it is checked with the sum of the digit. After sum of digits are stored, it is checked with the number. Okay, and here what happened, the student had stored the sum of digit in another variable. Okay, here he has used a third variable to swap. So if yes, very good. So when it is finding that the sum of digits is equal to the sorry, the sum of digits is truly divisible with the original number, so the next number has to be what, sum of the digits. See, everywhere the same thing has been done over here. At this particular time, when I found that 6804 is completely divisible with 810, what's my next number is becoming? What's my next number is becoming? My next number is becoming the quotient of the number, right? Let's see. See, this is my sum of digits and this is my number. So my next number is becoming the quotient. Let's see here, the student has stored the quotient of the number or not. But as per here, I couldn't observe the student has stored the quotient, while the student has stored the remainder, which is absolutely incorrect. I think it has to be n1 this. Now it's correct. But then n1 is storing n1. Okay, now it's correct, right? But lowercase n1 is equal to uppercase n1 divided by s. Then uppercase, why is it so? I don't think this is also necessary. I need I think the student has gone for multiple loops, single loops. That shouldn't be done. See, multiple while loops. I think this has to be this. See, this is a very lengthy program. I have not checked yet, but I think this will be the wisest way that you can do. So while if I'm finding n1 and store your n somewhere, okay, here exactly whatever the student has done, he has gone correctly. S need to be declared and it need to be initialized as 0. N is equal n divided by 10. Okay, so what we need to do, this has to be this. Everywhere this work has to be done, and here I need to check everywhere. There has to be another while which needs to check. Suppose here n, yes, and should be every time greater than 9. Do you remember the magic number? The same kind of logic will be used here. And here what will I be doing? I will be, after all of this particular smaller this inner while loop is completed, I will be replacing the value of n with s, and I will be taking s is equal to 0. Okay, so every time what will happen, it will be working unless and until my n will be a single digit number. But what if it will never be a single digit number? So for that I need to do one particular thing. Sum of the digit has to be divisible. Okay, so for this I need to do one thing. Let me do one thing. So here I will be putting a condition. If I'm finding that the number is completely divisible, then only I will be storing n is equal to s, s is equal to 0, and my loop will be continued. So I can use this. If I'm not finding it's not divisible, then else I will be breaking the whole loop. This is the correct way that we can do here. Okay, and when my whole of loop will be completed, when it will be coming out of the loop, which has to be a single digit number, which has to be a single digit number, my n has to be a single digit number. So after all of my loop is complete, I will be checking if n is lesser than is equal to 9. So that that is becoming, that is of course if a single digit number will be there, that has to be a Harsad number. Okay, that has to be a Harsad number. But okay, so here he has checked if n1 is modulus 2. Okay, it is both a Harsad as well as multiple Harsad. It is a Harsad but not multiple Harsad. Okay, so here what you need to do, here you can use a counter, that if once you are getting a situation where your number is divisible, so there you need to consider it to be only a Harsad number. But if you are finding frequently that yes, every of the sum of the digits is when divided with that particular number, it is also, it is divisible correctly, so there you can use multiple Harsad number. But here I have only checked whether that particular number is a Harsad number or not. Okay, but here I could feel due to multiple loops was not necessary, and here also the student has gone wrong here. Okay, so we can expect here number 9 out of 15 due to multiple errors in this. I could find error as this is very much lengthy as well. See, and modulus s is equal to 0, this is becoming lengthy. Then again I am using another while loop to store the another sum of digits. Till when this will be going, right? That is why if whole of the this particular dry run is somehow giving us answer, but also due to the presence of the lengthy step, it may be 11 out of 15. I think it should be between 10 to 11, because as this is very lengthy program that the student has written, and somehow by doing dry run it will be again be taking lots of time by the examiner. That's why between 10 to 11 you can observe this has to be. Now let us check disarm. Okay, if we are accepting a number from the user, and if we are finding a interesting 3-digit number is taken, 1 ka square 3, 1 ka, okay, 1 to the power 1, 3 to the power 2, 5. Okay, very good question. And then if you are adding them up, you are getting the, okay, disarm. If there are 4 number of digits like 1 to 4 9, you need to pick out 1 ka 1 to the power 1, 2 to the power 2, 4 to the power 3, 9 to the power 4. Okay, and at last whatever answer you are getting, if you are finding it to be the number that is equal to the original number, then you will be considering that the original number has to be disarmed. This is interesting and also an easy one. Let's see what the student has done. Okay, here the student has first created the logic of his own, right? Can you see, this is just a dry run that the student has done to follow this particular process. Okay, here the student has written the program. Okay, a number has to be accepted, correct, semicolon has to be given very properly, a number is accepted, acha, the original number is safely stored in and uppercase n, and here the student is checking the number of digits as well. Do we need to check the number of digits? Acha, yes, if we will, yes, the number of digits has to be checked, because if you will not be checking the number of digits, how you will be thinking of the last power. See here 1 2 3 4, because as there were 4 number of digits, that is why it was the first digit to the power 1, second digit to the power 2, then to the power 3, then to the power 4, right? So it has to be, yes, very very properly the student has only used a loop just to find out the number of digits. Very good. Then again he has used a loop. Here the digits are extracted from the last, so it has to be, okay, see, as the digits are will be extracted from the last, so as my counter will be, if there are 4 number of digits, my C will be 4. So what happened, so last digit to the power 4. If 1 2 4 9, what will be, if I will be taking from last to the power 4, then can I do like this, 4 to the power 3, then 2 to the power 2, then plus 1 to the power 2, sorry, 1 to the power 1. This is exactly what the student has done. See, from last to first. Then here this sum is stored very properly. Then C minus minus, so that this power will be reduced. 1 2 3, sorry, huh, this power will be reduced from, at first it was 4, right? 4, then it will become 3, then it will become 2, then it will become 1. So due to which this will become, due to the C. Now again, very nice, very nice, this is correct. And S is compared with, can you see, S is compared with not the lowercase n but the uppercase n, because this is where my original number is stored. Very nice, correct. Here very easily the student will be getting 15 out of 15, because everywhere he has gone correctly. Okay, now it's a last program. It's a duck number. What do we mean by duck number? A duck number is a number where a zero shouldn't be present at the leading place. Suppose I have taken 1240. This is a duck number. 1204, it's a duck number. 1024, it's a duck number. But 0124, it's not a duck number. Okay, so if a 0 is present at the leading place, so we won't be considering it to be as duck number. Except this, we can consider any of the number as to be as my duck number. But the best part, do you know what we can do? The best part is, here also we do not know the number of digits. Suppose if I have given a 4-digit number, 1492, what formula should I be using here to find out what is present at my first place? Let's see, 1492. If I will be dividing it with 1000, then what will happen? 1 ja 1000 492. Do you find the first digit? So if I am ever, so can I put a formula that if my number of digit is 4, if my digit is 4, but if I'm writing 10 to the power number of digits, let my number of digits is stored at d, so d minus 1. So whatever number is given to me, if I have found out the number of digits, and if I'm dividing that particular number with 10 to the power the number of digits minus 1, if I'm finding whatever quotient I'm finding, if that is not 0, that means that is a duck number. Yes or no? This is my point of view. Let's see what the student has done. The student has accepted a number. Originally it is stored. Number is not equal to 0 and shouldn't be 0. Due to C++, it will be counting the number of digits. That is perfect what the student has done. Now the number is stored again. I don't think so. Acha, n is equal to n. I don't think this was a necessary step, because as your original number, see, here the student has manipulated the value of uppercase n, but it need not to, the student need not to be worried, because the number is already stored in my n, and see here there is no semicolon that has to be done. I don't think it was a necessary step that need to be done. Let's see what the student has done here. Acha, again all of the digits was founded. Oh my god, it's a very lengthy step. Let's see. C is greater than 1, C minus minus, R is equal to every time. Acha, it has gone till the first digit. For this he has done such a lengthy program. Okay, he has started from the last digit and has gone till to the first digit, and then he has checked somewhere, I think, whether that is a 0 or not. See, what is this d plus plus? Let's see. Each digit are found out, and if r is found to be 0, acha, if the it has gone, acha, he has gone, suppose if my number of digit to be this, he has gone till this, and he has checked if anywhere he is finding that the number is 0, then what happened? He is considering that number to be as a duck number. This is what the student has done. See, that is why this is greater than 0. It will not be reaching till 1. That means from last he has checked all of the places. Acha, let's see, if anywhere he is finding, then he is checking. Nice, but I think he has not checked whether the first place is 0 or not. I think that is one of the very important step that has to be done. If my first place is found to be 0, then that will not be considered as duck number, right? He has only checked whether all of the places except the first place is having a 0 or not. This is only half of the program that the student has done. student has to check whether the first digit, see, first digit has not to be 0, and in the other places there has to be at least 1 0. Yes or no? And in my point of view, whatever I have done here, I have checked whether the last digit is sorry, is my first digit is containing 0 or not. If I'm not finding that it is if I'm finding that it is not containing 0, then what I need to do, then I need to check whether any of the number from that particular number is having 0 or not. Then only that will be found to be as duck number. So for that, we can write a program like this. While n is already, I am writing this after considering that d is already containing the number of digits. So here what I need to do, here if I will be writing, if I'm finding, let my number is here, number divided by number this, math.pow, I'm just writing the formula, 10 comma d minus 1. If I'm finding ever this, let me put a bracket, is equal to 0, then what happen, it will be break. Else I need to check whether a number is at least one time present or not in the entire program. So for this I would have used another while n is not equal to 0. Let p will be storing, you need to think that it needs to be declared. I'm just writing the code snippet, or you can directly check. If n modulus 10 is equal to 0, use a counter. Let me take c is my counter, c++. Okay, then n is equal to n divided by 10. My while loop is open and closed here, then it's closed here. Okay, then at last I will be checking that if my c is found to be greater than 0, then what will happen, then I can write, why will this become 0? See, here what will happen, if my first digit will be found to be 0, then it will be break, and when it will be break, so it will be directly coming to such a part where my whole of the program is the cursor has come to. So here if it is break, what will happen, the initial value of c is what, the initial value of c is 0. So here it will be checking whether the c is 0 or not. That is why in else part we can write, of course c is greater than 0 is checked by me. So if this particular statement will be break, then what will happen, my cursor will be coming to this, and as my leading place will be storing number 0, due to the presence of the break, my c will be checked here. And if my c will found to be is equal to 0, that I have written in my else part, so here what will happen, it will be printing duck number. This is one of the case. And if if my number is not containing 0 at my leading place, so what will happen, it will be enter into else part, and in else part what is checked, whether my 0 is present at any other part or not, because once it will be checking if it is present at any other part, the counter will be increasing 1 2 or not. So by this what will happen, if I am finding the counting, it is counting number of zeros except leading place, so there it will be printing what, it is a duck number. But what if there is never a 0 in any of the following, so what will happen, my c will still become 0, because every time this condition is false, so my c will still become 0. Due to this what will happen, it will again be jumping to my else part, and it will be printing, sorry, this is not a duck number, not a duck number, greater than 0, not a duck number. Did you get what I'm saying? This is the proper program that has to be written for duck number. And if my c is if any of the places still not containing any digit that is 0, so c is greater than 0, and here it will be duck number. This is how your program has to be written. Okay, now this is complete. If anybody will be asking you the duck number program, so after you will be finding the number of digit, you can come to this particular logic. I know this is slightly big, but it's easy. But here I could find some of the problem in this particular program. It has not checked whether the 0 is not present at the leading place or not. Otherwise all of the things are correct. See here, half of the portion that is written by me is written over here, but the student has not checked whether it is present at the leading place or not. Okay, so this was all about how you so by this what will happen here, your teacher or your examiner will be given around 12 from the 15. 3 marks will be cut just to check whether because you have not checked whether that particular zero is present or not present at the leading place, that is at the beginning. Okay, I hope this particular video was very much informative. By this you must have understood how your number based program is checked by the examiner and how this particular marks are denoted to you. Okay, thank you so much for watching till end. Prepare very well for your board examination. All the very best and bye bye.